Hello everyone, welcome to BYJU'S Exam Prep. So here I am with the Coffee with Concepts, and here I am going to discuss the important concepts that is used not only in the signals and system but also used in the communication systems many times in the digital communication. So that is nothing but the sampling. So the trick, how can you calculate the sampling very quickly, sampling frequency very quickly, that we are going to discuss today. And this is trick to calculate the sampling frequency for the low pass sampling. Okay, so let's start with the brief of the sampling theorem. Why the sampling is required whenever we want to convert the analog signal into digital one, then we have to apply the sampling theorem. This is the first step of converting the analog signal into the digital one. So what sampling theorem says? Sampling theorem states that any band limited signal which is having highest frequency component up to FM hertz can be completely reconstructed by its samples if the samples are taken at the interval of Ts less than equal to 1 upon 2 Fm or at the rate of Fs greater than equal to 2 Fm. So whenever you want to transmit any analog signal, suppose you want to communicate with your friend, then your voice is converted into the form of a digital signals. And because when we transmit it through the cable, because of the security purpose, it is converted into some other form. And then at the receiver, when it is decoded again by the receiver, that is maybe by your friend, and it is decoded by the system that he has, and it will convert back the into the original signal. So how it will convert? Because when you transmit the signal, it will be converted into digital form. That means it will be taken the sample of your voice. It will not completely transmit your signal or your voice. It will take the sample of that particular voice, and the sampling that it will take, and by the help of that sample the receiver has to reproduce your voice. So that is only possible when you will do the sampling keeping this theorem in mind. So you have to keep the sampling frequency which is greater than equal to 2 FM or the sampling interval less than equal to 1 upon 2 FM. So what do you mean by the signal which is band limited to FM? The signal which is band limited to FM means a signal which is having the highest frequency component FM. So after the FM it has zero frequency, that is known as the signal is band limited to FM. And if it is given or not, it is always present in the negative side also. Whenever you have the message signal, it will always be presented in both the side, positive and the negative by default. So if in the most of the case, if only positive side is given, then you can just draw the mirror image in the negative side, and here the bandwidth or the maximum frequency you want to calculate. So that maximum frequency is FM, that is the highest frequency present in your message signal, or you can also say it as the bandwidth of this particular signal x of t is also FM. The bandwidth of this particular frequency signal is also FM. So the bandwidth is also FM. So sometimes students calculate the bandwidth as the highest frequency minus lowest frequency, but don't miss this part that the bandwidth is always calculated from the positive side of the spectrum. So that is, in the positive side we have the highest frequency FM and the lowest frequency is 0. So FM minus 0 is FM. So that is how you calculate the bandwidth of the message signal or the maximum band limited frequency. So now you have to apply simply sampling theorem, which is Fs greater than equal to 2 FM. You will get the sampling frequency of that particular signal. But now suppose you have a random signal which is having the combination of the signals which is having more than one frequency component. So A1 cos 2 pi f1t, A2 cos 2 pi f2t, and so on up to An cos 2 pi fnt. So in this particular message signal, there are n terms having the different frequency component. Suppose the first term is having the frequency f1, the second term is having the frequency f2, the third term is having the frequency f3, and another term is having the frequency fn. Then how you will sample it, keeping the sampling theorem in mind? So that is nothing but the sampling frequency. When the multi-tone signal is given, then you have to calculate the sampling frequency by twice of maximum of all the frequency present in the message signal. So this message signal is having n number of frequencies, and out of n number of frequencies, whatever will be the maximum that you have to select and then multiply it by 2, that is your sampling frequency. So this is how you can calculate very quickly the sampling frequency for multitone signal. The multitone signals are those signals which is having more than one frequency component present in the signal. Now, if you sample any signal, then how many frequency component will be present after sampling? Okay, after sampling, before sampling we have n frequency component, but after sampling, how many frequency components are present? That is given by the message signal frequency, which is f1, f2, f3, and so on up to fn, and then fs plus minus f1, fs plus minus f2, fs plus minus f3, and so on up to fn, and 2fs plus minus f1, 2fs plus minus f2, and 2fs plus minus f3, and so on. So this is we calculate by the using this particular equation, ms of f. This is your sampled signal spectrum. It is 1 upon fs, 1 upon ts. So that is your fs summation n equal to minus infinity to infinity m of f minus nfs. So by this formula, this is, you can see that n multiple of fs is there. Nfs is there, that is multiple of fs. Hence, we have f1, fs, 2fs. So fs, that is the multiple of fs, integer multiple of fs plus minus f1, 2fs plus minus f1, 3fs plus minus f1, and so on. Similarly for f2, fs plus minus f2, 2fs plus minus f2, and so on. So this is the very useful trick to calculate the sampling frequency if there are more than one frequency component, which is known as multi-tone signal. Now the sampling frequency you can calculate very quickly again if the signals are multiplied in the time domain. So M1t, M2t, M3t, and so on up to Mnt, if there are n components and they are multiplied together, then how can you calculate the sampling frequency for this message signal to be sampled? This message signal is to be sampled, which is itself is multiplication of the number of frequency. Like it can be in the form of sine A, cos B, sine square C, like that. Okay, so all these are multiplied. Now we have the multiple frequencies which are in the multiplication form. Then how can you calculate the sampling frequency? So sampling frequency for such type of signal, first of all, calculate the maximum frequency of each individual term. Calculate the maximum frequency. I am saying, mind it, that I am saying maximum frequency of each component. So if there is a message signal M1t, calculate its maximum frequency. M2t, calculate its maximum frequency. Likewise, for MNT, you calculate the maximum frequency. And now, sampling frequency is twice of addition of all the frequency. So now, once you calculate the maximum frequency of each component, add them together, and after adding, the message signal will be band limited to that particular frequency. This message signal will be band limited. This message signal will be band limited to addition of all the individual frequencies. So it will be an addition of all the individual frequency. This is band limited to that, and according to sampling frequency, we have to just take the double of the band limited frequency. So the band limited frequency is addition of all, and now just multiply it by 2, you will get the sampling frequency. So this is how you can calculate if the signals are multiplied. Similarly, if the signals are convolved in the time domain, then also you have to calculate the maximum frequency of each individual term. Like M1t is having maximum frequency f1, M2 is having maximum frequency f2, and so on. And after that, find out the minimum frequency. So whatever will be the minimum frequency, the message signal will be band limited to that particular minimum frequency. And once you find the message signal is band limited to which frequency, you just need to double it. So once you get the minimum frequency of out of f1 to fn, just double it to get the sampling frequency. So sampling frequency is twice of minimum of f1, f2, f3, and so on up to fn. In this way, we can calculate the sampling frequency of single tone, multi-tone signals which are multiplied in the time domain, signals which are convolved in the time domain. So this is it about this particular copy with concepts, and we will come with the next concept with in the next series, that is on Sunday. Thank you.